Okay, today what we're going to be doing is we're going to be taking section 5.3 and we're going to solve trig equations. Now, there are a couple of sets of directions in this section, and the first set will tell you to find all the solutions 0 to 2 pi, and then the other set will say find all of the solutions, and it's basically for every coterminal angle that is on the unit circle and off the unit circle. So that's where you're going to have 2 pi k or you're going to have pi k. Then I'll talk about the difference between those as we go along in each example. So the very first thing we're going to do is number 1 here, and this is going to be 2 sine of x minus 1. So the very first thing you're going to do is you're going to solve for x just like you would any other equation. So that means we're going to take the 1 over to the other side. Then we're going to divide by 2. And then to get rid of the sign, you're going to take the sine inverse, or arc sine. And then your brain needs to immediately say, I need to have a positive angle. So where is sine positive? Sine is positive in quadrant 1 and in quadrant 2. Yes? So you're looking for the two angles on the unit circle that are going to have that. So I'm going to pull up my unit circle. So if we look in quadrant 1 and quadrant 2 and we're looking for a sine of 1/2, what that means is if you have a sine of 1/2, that's our y value, and that's going to be at 30 degrees. And then in quadrant 2, it's going to be at 150 degrees. So if we come back over to our problems here, that means x is going to be equal to pi over 6, which is our 30 degrees. And then it's also going to be equal to 5 pi over 6, which is our 150 degrees. Now, if this was between 0 and 2 pi, these would be my two answers. However, if it's all angles, then that's going to be pi over 6 plus 2 pi k, and then it's going to be 5 pi over 6 plus 2 pi k. And here's why it's 2 pi k rather than pi k, because here is pi over 6. In order for me to land on pi over 6 every time, if I add pi to it, it only puts me over here. And in this quadrant down here in quad 3, that is going to have a negative sign, and I don't want it to be negative, so you cannot do that. So that's why you have to add the 2 pi k every time to land here. You're landing there every time you go around the unit circle. And the same thing is going to happen if I'm at 5 pi over 6. If I only add pi units to it, I'm at the diagonal angle, and that is again negative there, so I don't want that. I need to land here, and I'm going to add the 2 pi k every time so that we land on that as the coterminal. So that is what you're going to have with those angles. Okay, so those are your two answers. The next one, I have the next example, number 2. These are not number 2 in your textbook, this is just number 2 example. So the very first thing I see is that I have a sine squared and a cosine. They are not the same trig function, so I have to use the trig identities to get them into the same one. Since I have cosine, I'm going to keep and solve sine squared of x for cosine squared. So this is going to give me 2 times 1 minus the cosine squared of x is equal to 2 plus the cosine of x. So I'm going to distribute 2 minus 2 cosine squared of x is equal to 2 plus the cosine of x. I'm going to take everything over to the right-hand side, so 0 is equal to a 2 cosine squared of x plus a cosine of x plus a 2 minus a 2. Okay? And so the 2's are going to cancel out, and you're going to have 0 is equal to 2 cosine squared of x plus the cosine of x. And from here, you're still factoring, so this means I have a GCF, and my GCF is going to be a cosine. So if I pull a cosine out, I'm left with 2 cosine of x plus a 1. So from here, I'm going to break this down into 2. I'm going to have that the cosine of x is equal to 0, and I'm going to have that 2 cosine of x plus 1 is equal to 0. Okay? So this means that x is equal to the cosine inverse of 0. So where on the unit circle is my x value going to be 0? So if you come over here to our nice little unit circle, and you're going to say, where is that going to be 0 at? Where's your cosine 0? Your cosine is 0 at pi over 2 and 3 pi over 2. So let's go back over here and write that down. Now, those are my answers if you're between 0 and 2 pi. Okay? However, if I come over here, what I'm going to do is say, all right, if I'm at pi over 2, how do I get to 3 pi over 2? Well, the way I get to 3 pi over 2 is by simply adding pi units to that. So that means x is equal to pi over 2 plus pi k. Every single time. It'll land twice on one revolution. So that is why you're going to be using the pi over k. Okay? So those would be your two answers depending upon what the direction says. And then over here, I'm going to solve this one. And if I solve this one, I have 2 times the cosine of x is equal to -1. So the cosine of x is equal to -1/2. And x is equal to the cosine inverse of -1/2. So we need to think quadrants, and I need to be negative. So that means you are at negative plus or negative negative. So you're in quadrant 2 or 3. So I need to know when my x is going to be at -1/2. So I'm going to come back over to my and that is going to be at negative is going to be at 2 pi over 3 and at 4 pi over 3. That is what you are going to have. So let's go back over here, and you're going to have 2 pi over 3 and 4 pi over 3. And again, this answer would be for when it is between 0 and 2 pi. And then if I wanted it to be my other answers, so let's look at that. Your angle's here, and your angle is here. That means that I cannot add pi units to get them. That means I have to add 2 pi units to get them. So that's going to be 2 pi plus 2 pi k and 4 pi over 3 plus 2 pi k if the answer says multiple. Okay? So that brings us to number 3. Number 3, sine squared plus cosine of x plus 1 is equal to 0. So again, I have 2 different trig functions. So this is going to be 1 minus the cosine squared of x plus the cosine of x plus 1 is equal to 0. So I'm going to go ahead and drop those parentheses. The 1s are going to give me a 2. So negative cosine squared of x plus a cosine of x plus a 2 is equal to 0. Then I'm going to pull out a -1, making that the cosine squared of x minus the cosine of x minus the 2 is equal to 0. And then we're going to factor this into 2 binomials. This is going to be the cosine of x and the cosine of x. And I have to use factors of 2, which are 1 and 2. And I need a negative inside, so that means the 2 is negative and the 1 is positive. This -1 is irrelevant now, so I have the cosine of x plus 1 is equal to 0, and the cosine of x minus 2 is equal to 0. So the cosine of x is equal to -1, so x is equal to the cosine inverse of -1. So where is my x value on my unit circle equal to -1? My x value on my unit circle equaling to -1 is going to be at pi units, and that is the only place, okay? And then the cosine of x is equal to 2, so x is equal to the cosine inverse of 2. Well, I'm going to tell you straight up, if you come to Desmos and you type that in, you're going to see that that's undefined. And the reason why it's undefined is because we have a radius of 1 on our unit circle, so therefore it's really not possible. So that means this is not defined, it's undefined, so my only answer is going to be x is equal to pi. Okay, so number 4. Sine of x plus the square root is equal to negative sine of x. Set this thing equal to 0, so I have the sine of x plus the sine of x plus the square root of 2 is equal to 0. So 2 sine of x is equal to negative square root of 2 by subtracting that over. Divide by 2. So I have x is equal to the sine inverse of negative square root of 2 over 2. Now obviously, I need to find on my unit circle where sine is negative. And sine is negative in quadrant 3 and in quadrant 4. So what angles in quadrant 3 and in quadrant 4 have a sine value being negative square root of 2 over 2? Well, that is going to be at 5 pi over 4 and at 7 pi over 4. And this is going to be on the interval of 0 to 2 pi. Now, if I was not on that interval, then you are going to have 5 pi over 4 because they are right beside each other. I only need the negative portions, so I cannot add pi. I'm going to have to add 2 pi k. So there's one answer. And then 7 pi over 4 plus 2 pi k if I was not on the interval of 0 to 2 pi. Okay? Next, number 5. Number 5, I'm going to set this thing equal to 0. So I have the cotangent of x times the cosine squared of x minus 2 cotangent of x is equal to 0. So you need to find your GCF and go fish. So if I pull out a cotangent of x, what remains is a cosine squared of x minus a 2 is equal to 0. So we're going to go from there. We're going to set each GCF equal to 0 and each parenthesis equal to 0. And so x is equal to the cotangent inverse of 0. So understand that cotangent is x over y. So in your head, your brain needs to be saying, hey, cotangent is equal to your x value over your y value. So where on my unit circle is my x value going to be a 0? So if I'm looking for when my x value is a 0, that's going to be at pi over 2 and at 3 pi over 2. Yes? Now, let me get back there. You also need to remember that whenever you use the cotangent is going to be from a range of 0 to pi units. So if it's a range from 0 to pi units, your brain needs to automatically say, I need to cross off the 3 pi over 2 because it's not possible, because it's outside of my range of where I'm going to be utilizing it, because arctan is only used, or arc cotangent is only used between 0 and pi. So that is why 3 pi over 2 cannot be used. So then over here, we're going to go ahead and finish this to give me a 2, and then we're going to take the square root of that. And when we take the square root, we get plus or minus 2. And then x is going to be equal to the cosine inverse of plus or minus the square root of 2. Going back over to our Desmos, I need your brain to recognize that you are going to be taking the square root of this function. And because of that, you need to see that it is still undefined because it is greater than the value of 1, which means this is not possible. And so the only answer that you are going to have on this problem is simply going to be pi over 2. That is the only answer that you have on this problem. Okay, so be very careful, making sure that you're thinking outside the box and understanding how each of them go. Okay? Number 6, 3 tangent squared of x is equal to 1. So I'm going to divide both sides by 3. So I have the tangent squared of x is equal to 1/3. So I'm going to go ahead and take the square root. So the tan of x is equal to plus or minus 1 over the square root of 3. And my brain likes to rationalize that because that's what I memorized on my unit circle. And whenever I memorize that, I need to know what angle has a square root of 3 and what angle has a tan inverse of negative square roots of 3 over 3. Okay? So your brain needs to look here and your brain needs to say, I need to know when tangent is positive and I need to know when tangent is negative. So you are going to have all 4 quadrants and you're going to have answers in every one of them. And the most important thing that your brain needs to understand is that the tangent of the angle of 30 degrees is the square root of 3 over 3. So what you have here is it is positive at pi over 6, and then it's also positive at 5 pi over 6. Now the beautiful thing about this is if you take the angle that is right here in quadrant 1, which is pi over 6, and I add pi units to that, that gives me my diagonal angle, which is going to be 7 pi over 6. 7 pi over 6 is where it's going to be positive, okay? So these two will give me both of my positive answers, yes? Okay? But I only need to add pi units to that to get both of these. Why? Because these both will be positive, and hold on, let me write that down for you so you know what I'm talking about. You should have written it over here. Okay, and then 5 pi over 6 is going to be right here, and if you add pi units to that, you are going to get to the 11 pi over 6. So you're going to get all 4 angles, but instead of writing it as 4 angles, what you're going to write is you're going to do 11, you're going to do pi over 6 plus pi k, and you're going to do 5 pi over 6 plus pi k. And that is giving you every one of those angles because you're getting the diagonals out of them as well. Okay, that's getting all 4 angles. Okay, number 7. Number 7, this is equal to 0 already. It has only signs, so I can go straight to factor. And that's very helpful. Less work for you. I need a negative here and I need a positive here. So then I'm going to go ahead and give you that the sine, 2 sine of x plus 1 is equal to 0. So the sine of x is equal to negative 1/2. So x is equal to the sine inverse of negative 1/2. Now again, what quadrants is sine negative in? It's negative in quad 3 and 4. So you are looking for the angle that has a sine of 1/2 negative, and that is going to be at 7 pi over 6 and 11 pi over 6. Now again, if you wanted to have multiple, you would put the plus 2 pi k here because they are not in diagonal quadrants. So since it says between 0 and 2 pi, these are your 2 answers for that one. So my second one, I have the sine of x minus 1 is equal to 0. So the sine of x is equal to 1. So x is equal to the sine inverse of 1. And where on your unit circle do you have a y value of being 1? And that y value being 1 is going to be at your pi over 2 angle, which is just going to be 90 degrees. Okay, next, number 8. Now, in this problem, we have 2 different trig functions, and one is squared, so that means I have to keep the cosine, and we're going to go ahead and make this a 1 minus a cosine squared of x. And we're going to simply distribute and factor. So 2 minus 2 cosine squared of x plus 3 cosine of x minus 3 is equal to 0. So we are going to make this a negative 2 cosine squared of x plus a 3 cosine of x minus a 1 is equal to 0. Now when I do this, I am either going to bring everything over to the right hand side or pull out a negative 1, and that's what I do here for you. And then I factor. That negative 1 really is not necessary, but I'm putting it there so that you understand that I did not drop it. I carried it along throughout the entire problem. Okay? So I need to have a negative 1, I need to have a negative 3, so they both need to be negative, but I need a positive 1. So now from here, I am going to say that this negative 1 does not matter anymore, and I have 2 cosine of x minus 1 is equal to 0, so the cosine of x is equal to positive 1/2, so x is equal to the cosine inverse of 1/2. Okay? So this is not specific to just the region 0 to 2 pi, so this is where I need to think a little bit, and I need to say, okay, well, where is cosine positive? Cosine is positive in quad 1 and in quadrant 4. So what 2 angles am I going to get? They're not diagonal quadrants, so therefore I cannot do my trick of pi k. I have to do 2 pi k. So my cosine is going to be at pi over 3, and I'm going to simply add 2 pi k units to that to get to every one of my lovely little angles there. I have to add that every time 2 pi to get to it. My other answer is going to be x is going to be down here, and that is going to be at 5 pi over 3 plus 2 pi k again, because again, I have to add 2 pi units to get to that every single time. So those are my 2 answers for there. Now, let's come over here and finish this one. The cosine of x minus 1 is equal to 0, so that means the cosine of x is equal to 1, so x is equal to the cosine inverse of 1. So where on my unit circle is my cosine value equal to 1? And we all know that is 0. Now, it is not just at 0 though. because it is not asking for the region 0 to 2 pi, so that means you have to add 2 pi units to that, which means x is just 2 pi k. A little bit strange because that 0 doesn't do anything to that, so it's just going to give you 2 pi k. Okay, we have 3 more problems I want to get through because they're all unique and some of them are homework problems, so I want to make sure that you understand to look at your homework as look at your notes as you're doing your homework tonight. So here we go, secant squared plus tan of x is equal to 3. Now in this problem, again, I have 2 different trig functions. I'm going to take my squared one and I'm going to make a substitution, making that 1 plus tan squared of x plus the tangent of x minus 3 is equal to 0. So I'm doing a couple things at one time here. So I have tan squared plus the tangent of x minus 2 is equal to 0. And again, factoring. Factors are 1 and 2, and I need to have a positive one, so the 2 is positive and the 1 is negative. So I have the tangent of x minus 1 is equal to 0. So the tangent of x is equal to 1, so x is equal to the tan inverse of 1. Now, where is tangent positive? Tangent is positive in quadrant 1 and in quadrant 3. That's where you're at. So I'm looking for those 2 angles. And those 2 angles in quadrant 1, that's pi over 4. And I'm going to have to add something to get to that. Okay? And let's think about this. They're diagonal, so whatever I choose here, if I add pi units to it, it's automatically going to bring it to me there. So pi over 4 and then 5 pi over 4 are my angles that I'm wanting. But I can add pi units to that to get to it, so that's the only one that I absolutely have to have. Okay? So let's come back up here, and I have the tangent of x plus 2 is equal to 0. So x is equal to the tan inverse of 2. Now, the tan inverse of 2, negative 2, sorry. Again, we need to think quadrants. Tangent is negative in quadrant 2 and in quadrant 4. So these are the 2 quadrants I am in. So these are not angles that we memorized. So we have to think reference angle. So reference angle is what I taught you previously. So we are going to come over here to our calculator and we're going to type in the tangent inverse of simply 2. Not negative, because the negative tells us what quadrant we're in. So that value, rounding 4 decimal places, is going to be 1.1071. That is our reference angle. Now, if we're in quadrant 2, when we are in quad 2, the way we get that is we're going to take pi minus that decimal. And that is going to give us our quadrant 2. Now, I'm going to cheat. That is not where I want to be. I'm going to cheat, and I'm going to simply type right up here, pi minus that. And it's going to give me this. Because I want to land in quadrant 2. Pi is 180 degrees, and if I subtract that off, I'm going to get that 2.0344. Okay? However, I also am in quadrant 4. So to get my quad 4, well, now I'm going to take 2 pi minus that value. So that's going to go back over here. And I'm going to put a 2 in front of this now. And whenever I get that value going out 4 decimal places, I'm going to get 5.1760. So 5.1760. And the reason why is because we did not know what the tangent was at negative 2. So the 2 answers that we're going to have are 2.0344 and 5.1760. Something you need to know for your homework. And I'm going to specifically say that it is going to be between 17 to 30. This is like 17 through 30. So really pay attention to that. So if you get something that you're like, hey, I don't know what that is, that's not on my unit circle, I have to use the calculator, you are going to use the reference angle, and then you're going to use your horizontal axis, which is pi and 2 pi, to get your other angles. If you're in quadrant 3, you're going to take pi plus the angle. Okay? So you need to make sure you're paying attention to that. All right, this is like a math Excel problem. And the directions say find the solution on the interval of 0 to 2 pi. So what we're going to do is it's already in factored form for us. So since it's already in factored form, I'm going to go ahead and set each of these equal to 0. which seems pretty straightforward, okay? So x is equal to the cotangent inverse of 0. And where is my cotangent have an x value of 1? I have an x value of 1 whenever I am at pi over 2 and 3 pi over 2, okay? But again, we need to think like we did previously and understand that we're between 0 and pi whenever we're utilizing the cotangent inverse function. So I'm going to need to look at my pi over 2. So that's my answer there, and I need to check for some things here. Coming back over here to tangent, I'm going to have that the tangent of x is equal to the square root of 3. So x is equal to the tan inverse of the square root of 3. What quadrant are we in that tangent is positive? Well, that puts me in my quad 1 and in my quad 3. Okay, but again, our brain needs to understand that if we are in one of these two quadrants, and I understood that I memorized that the tangent of the angle, an angle that has the tangent of the square root of 3 is going to be pi over 3 and then 4 pi over 3. Okay? That's beautiful. That's good to go. Those are the answers we're looking for. But again, my question is if I were to plug these in, would I have any extraneous solutions? These ones right here, you're golden. You're golden because it is not dividing by 0. Anytime you have 0 involved, 0 is wicked because we're talking tangents and cotangents. Tangents are reciprocals of cotangents, meaning if you have a tangent of 0, then its reciprocal is undefined because you're dividing by 0 now. So we kind of need to go back up here and we need to check to see if we have any extraneous solutions. So the cotangent at pi over 2 times the tangent at pi over 2 minus the square root of 3 is equal to 0. I don't have to check these answers over here because they are not zeros, but over here they are zeros, so I need to think about this. The cotangent at pi over 2 is going to be my x-coordinate over my y-coordinate, so that's 0 over 1, which is 0. My tangent of pi over 2 is going to be my y-coordinate, which is 1, over my x-coordinate, which is 0. Okay, well, what is 1 divided by 0? That's undefined. I don't care what this number is. I can never do a calculation with undefined in the problem. So therefore, this is not possible, meaning this is not an answer. My only two answers are going to be right here. The cotangent of pi over 2 is not a possible answer because you cannot plug and chug and get undefined in a calculation and be able to continue that calculation out. Okay? All right, we have one last problem here that I'm going to talk about with you. And this is also on Math Excel. And I believe this is similar to problem number 16 on Math Excel, but let's make sure. It might be a different one, so I'm sorry if not. So immediately I look at this and I have all tans, which makes me very happy. So that means I'm going to go straight to factoring. So 3 tangent of x and the tangent of x is equal to 0. I need to get 11, so that's an 8 and a 1, and they're both positive. Okay? So I have 3 tan of x plus 8 is equal to 0, and the tangent of x plus 1 is equal to 0. Great. So I have the tangent of x is equal to negative 8/3. So that means x is equal to the tan inverse of negative 8/3. Okay, your brain should be thinking some things here. This is very similar to what we did in this problem right here, because do you see this? That's negative 2. We have this funny reference angle thing going. So that's exactly what we're going to do with this one right here. I'm going to say, hey, where am I at? What quadrant am I at that I am negative? Well, I am negative for tangent in quadrant 2 and 4. That's where I'm at. So my reference angle, I have to actually take the tangent of 8/3, the inverse of that. So I'm going to come over here, and I am going to type in the tan inverse of 8 divided by 3. And it gives me this. So I'm going to go out 4 decimal places. So 1.2120. Okay, Okay, that's my reference angle. The problem is I need to now be in quadrant 3 or quadrant 2. So my quadrant 2 is going to be pi minus this, and then my quadrant 4 is going to be 2 pi minus this. So I'm going to come back over here, and I'm again going to cheat, and I'm going to say pi minus, and I'm going to get 1.9296. 1.9296, and that's what you are going to get there. That is one answer. Then I'm going to come back over here, and in place of this pi, I'm going to throw in a 2, and that's going to give me 5.0712. 5.0712. These are approximations. These are approximate values, okay? So we've solved the left-hand side. Now we need to solve the right-hand side. So how do I do that? I need the tangent of x is equal to -1. So when do I have a tangent being -1? Okay, well, what quadrants are we negative in? Well, we already talked about that over here. We're in quadrant 2 and we're in quadrant 3. We memorized our unit circle, so this is a 45-degree angle. What is my 45-degree angle in quadrant 2? That is going to be 3 pi over 4. What is my 45-degree angle in quadrant 4? That's going to be 7 pi over 4. So these are your exact angles that you memorized off the unit circle, and those are your approximate angles that you are getting off of your calculator using your reference angles that are also going to give you your 4 angles, your 4 answers, okay? So tonight's homework, you are going to owe me page 364, 7 through 37 odd, and I'm going to stop my recording now, and then you guys can have the other one for your homework afterwards, okay?